Good morning, Chem Peeps. We're talking about naming chemical compounds. I'm starting with this page first because this is from a prior video on polyatomic ions and oxidation numbers, and you can find that video on TikTok and on YouTube. But why I'm referencing this chart is because we're going to need these polyatomic ion formulas and names. We're going to need to remember how and where to find metals and nonmetals on the periodic chart. And I had also listed common transition metal ions that we use and the cross-up method, all videos that I've talked about before. I've added Roman numerals. If you haven't been exposed to Roman numerals, maybe in math class, here is 1 through 10, and we are going to use that in some of the naming of our compounds. So I'm going to give you 5 examples today, explaining how to name the compounds. The first type of compound that you're going to run into is a metal that is found in column 1 and 2. That would be our alkali and alkaline earth metals, and paired with a nonmetal. Now remember, the metals are on the left side of the periodic table and the nonmetals are on the right side, just beyond the diagonal divide. Looking at this compound, I can clearly see that magnesium is found in column 2 or family 2, the alkaline earth metals. And so it's very simple. And of course, fluorine is a nonmetal. The nonmetal name is going to change with an IDE ending. So fluorine is going to become fluoride. And magnesium is just named. So the name of this compound is magnesium fluoride, and that is how you name that category of compounds. Let's look at the next one. Our next compound does indeed have a metal, which is lead, and lead is a transition metal. And we talked about in prior videos that the transition metals can have multiple oxidation numbers, and it's very, very important when you're using or naming a compound that has a transition metal that you tell me what oxidation number that compound or that element has in the compound. And of course, the nonmetal is sulfur, and it is again going to get an IDE ending. So harking back on the video that I talked about oxidation numbers, we are going to have to cross up the subscripts. The subscripts that are seen in this compound are here. There's no number there, so we assume a 1. And then, of course, the 2. We cross the number up to the opposite ion. So the 2 is going to come up here. The 1 is going to go there. The first one is going to be positive. The second one's negative. The final step is checking the one on the right. Now, go back to your periodic trends for oxidation number charts. Sulfur is found in oxygen's family. The trend for oxygen's family is a -2. So this 2-to-1 ratio has been reduced. I need to return it to its original state. So 2 times -1 is going to give me a -2, which we know that family is going to have. But what I do to one side, I must do to the other. So 2 times 2 is a +4. That means this lead is a +4 oxidation number. And so when we name it, we say lead. And then I have to tell the oxidation number with a Roman numeral that means 4 in parentheses. So 4 is the IV. And then, of course, we name the nonmetal, which is sulfur, with an IDE ending. So it's lead 4 sulfide. Let's look at the next example. Okay, our next compound has more than 2 capital letters. Up to this point, we've only looked at compounds that have 2 capital letters, a capital letter for the metal and a capital letter for the nonmetal. In this one, we have barium, which is a metal found in column 2. And then we have oxygen and hydrogen. And this should tell us when we have more than 2 capital letters that we have a polyatomic ion present. So this is going to be a metal found from column 1 or 2 paired with a polyatomic ion. So that's where that chart's going to come in handy. You want to look for a formula that looks like a capital O and a capital H on your polyatomic ion. And in this case, it is called hydroxide. So when we're naming compounds that have metals from column 1 and column 2, it's pretty simple because we just say the metal name, which is barium. And then whatever the polyatomic ion name is, we say that. So it is hydroxide. So the name of this compound is barium hydroxide. Let's look at the next one. In this compound, we again have more than 2 capital letters. The metal that is found here is found in the transition metal portion of the periodic table. Therefore, we will have to use cross-up to use Roman numerals. The other portion of the compound, a capital C and a capital O with a 3, is a polyatomic ion, and we need to look at our chart. When we look at our chart for polyatomic ions, this is carbonate, and that 3 is part of its formula. Because there's only one copper and one carbonate, there are no parentheses around the carbonate. But I'm going to put them there first before we do cross-up because I do not want to move this 3. This 3 belongs to the carbonate identity. What numbers are we going to cross up? Well, let me change my color here. The colors that we're going to the numbers we're going to cross up are found here, which there are no numbers, which we assume are 1s. So I'm going to cross a 1 up to above the carbonate and a 1 up to the copper. The first one is always positive. The second one is always negative. But we do need to check carbonate's formula on our chart. And it is not a -1. It is actually a -2. How can I go from -1 to -2? I multiply this ratio by 2. What I do to one side, I must do to the other. So this copper here is a copper 2. And so when we go to name this, I need to put that oxidation number in Roman numerals with the name. So copper, and then in parentheses, I need the Roman numeral for 2, which is 2 I's together. And then I just name the polyatomic ion, which is carbonate. Okay, last example. Let's look at it. There aren't too many compounds that are like this, but we can put 2 polyatomic ions together because there are a few positive polyatomic ions. Most of them are negative. So in this example, we actually have 2 polyatomic ions. We have the NH4 and then we have the NO3. And looking at my chart, if I look at them, this one is called ammonium. So we just name the polyatomic ion, which is ammonium. Then we look up the formula for NO3, and it is nitrate. So we just name it ammonium nitrate. So there are 5 examples of different types of compounds that you may have to name. If you have a metal paired with a non-metal or a polyatomic ion, it's pretty simple because you just name the metal. If you have a metal from the transition area, you're going to have to do cross-up. Whether it's with a polyatomic ion or just an anion. You need to do cross-up so that that cation or that metal has a Roman numeral dictating what charge that it has in the compound. And of course, all nonmetals get an IDE ending. If you need more examples, find me on YouTube at Chems Chem Chat or TikTok, same handle, Chems Chem Chat. Talk to you later.